Alright, another big old triangle to solve. So, you got 123, 37. Add those together, you get a nice, neat 160. And if I subtract that from 180, that's just an indirect way of telling me that that's 20. So, because I have this angle on this side, I'm going to go ahead and use the law of sine. So, sine of 20 degrees all over that side. And I can randomly pick z or x. I'm just going to pick z. Sine of z all over side z. So I'm trying to find this. And here we go. So sine of 20 degrees. And that's 0.342 times z. So 0.342z equals sine of 37 times 5, I'm multiplying that way, gives me 3.009. Divided by 342, and I get 8.8. Let's round it. 8.8. Can't use Pythagorean theorem because that's not a 90, so we're going to use the law of sine one more time to find x. So, sine of 123, that's x all over side x. And I'm going to go ahead and use these two values again. And so that's y and side y. So 0.342, I'm just stealing sine of 20 here, all over 5. So I'm going to go that way. 0.342x equals, figure this out, multiply it by 5. 123 times 5. Whoa. I don't know. Sine of 123 times 5. Alright, I hope that's right. Hope I didn't hit buttons wrong. I'm going to round that to 4.2. Divide. And so I get 0.342, 12.3, let's call it. So x is 12.3. And we just solved the triangle. There she goes. All right. Okay, so number 29A. Don't take the bait. If this was a 90-degree triangle, we'd have 5, 12, 13. And so don't just assume this is 90. Don't do it unless you have evidence that supports it. Solve the triangle. Find all angles. Well, all we have is 3 sides. We've got to manipulate law of sine or law of cosine. We have no letters here, so I'm just going to randomly slap them down here. And then notice we can't use law of sine because we don't have any angles. So we're stuck using this. Now there's 3 variations, but I'm just going to stick with this because that's what I have written down. So c squared would be 144, and a squared would be 25, and b squared would be 100, minus 2 times a times b times cosine of angle C. So a little bit of math here. 144 equals 125. This is 50 times 2, so it's 100 cosine of angle C. Do not subtract 100 from 125. These are not like terms. Tempting, but don't do it. Get rid of that. And that would be 19 equals negative 100 cosine of angle C. Divide by negative 100. Divide by negative 100. So I get cosine of angle C equals, clear that out, 19 divided by 100. And I get negative 0.19. Now, my insecurities, okay, I subtracted good. Alright, so cosine negative 0.19, let's figure out what that is. So second cosine negative 0.19, we get 100.95. Let's just call it angle C is equal to 101. Getting a little crazy with that rounding, but I'm going to do it. All right, so we get 101. And now that we have this angle, this side, we can use the law of sine. So sine of angle C all over side C equals sine. I'm just going to pick B over side B. So here we go. Sine of 101 times 10, cross multiplying this way, I get 9.8 equals 12 sine of B. Divide by 12, divide by 12. 0.818 equals sine of B. So I'm going to find it by using second sine. So here we go. Second sine 0.818, 54.9. And that is angle B, 54.9. So if we take this plus this, subtract it from 180, we're good. So 54.9 plus 101, and we get 24.1 degrees. There we go. Find the area of the triangle. Well, we've got three different formulas. I'm going to pick one. 1/2 AB sine of angle C. That is our little area formula. So we just plug things in where it belongs. There's side B, or side A. Side B is 10. And then sine of angle C, which is 101. Crank that out. So it's 50 times a half, or 25 times whatever that is. So we're going to go sine 101 times 25, we get 24.54. So approximately 24.5 square units for our area. Stick a fork in that. All right, number 30, I got ahead of it a little bit, got the drawing here somewhat to scale. 106, more than 90, 52, looking good. They give us angle M and then side M. Now, what I like to do, because our formulas are in terms of A, B, and C, I don't know, call me crazy. I'm just going to call that an A. I'm going to call that my B, that my C, and then just deal with stuff. So this has to be side A. So what I'm going to do is, just for kicks and giggles, add these together, and that's 158. Subtract that from 180, I know that's 22. So there, I've got as much information as I can. It's finding the area. Got these three formulas. So now I have side A, and so we're going to use either one of these two. And so now my job is to either find side B and use this one, or side C and use this one. So I'm just going to stick with this one just because it's on the top. So I'm going to find side B using the law of sine. So sine of 106 over side B, and I'm going to go sine of 52 all over 12. I'm going to pause the video because we've seen the law of sine enough. You don't need to see me do the work. Okay, so I got B is 14.6 using the law of sine. You can see my work if you need to look at it. I'm going to plug all the information into here. 1/2 times A times B times sine of angle C, and I'll be right back. So multiply that by that by that by that, got 32.8 square units. Call her good. All right, so Jim and Rob are standing on the seashore. I just put them right here, picturing the beach here. 10 miles apart, 10. The coastline is a straight line between them. Perfect world in math. Both can see the same ship. Here it is. The angle between the coastline and the line between the ship and Jim is 35. The angle between the coastline, blah, 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 is 45 between Rob, coastline, and the ship. So there it is. So it says, how far is the ship from Jim? So they're really asking us to find x. Now what I'm going to do, just to stick with our law of sine, law of cosine, is I'm going to stick with A, B, and C. And so that makes this A. So they're saying find side A. Well, 45 and 35 adds up to a nice little 80, convenient. If I subtract that from 180, I get 100. So that little piece of information kind of sets it off. So I'm going to use the law of sine. Sine of 100 over the opposite side equals sine of angle A all over side A. And again, we've seen the law of sine a million times. I'm going to do the work, and I'll be right back. All right, so just found this, cross multiply, solve. The distance is 7.2. Are we talking miles? Yeah, 7.2 miles. So there you go. All right, on to number 32. All right, we're entering vector land. As soon as I look at this, we need to remember that I equals 1, 0. That's our unit vector. And J is our other unit vector, 0, 1. Now, if we multiplied I by 2, we would just get 2, 0. If we multiplied this by 3, we would get 0, 3. And if it says to subtract that, 2 minus 0 is 2. 0 minus 3 is negative 3. I'm sure there's different ways to think of that. But it says sketch it. Well, because of these little pointy guys that look like parentheses but not really, this is called component form, which tells us it originates. These are the end point of a vector. So if I come on in here, there's my x-axis, there's my y-axis. I'm going to go 2 to the right, down 3. And there it is. There's vector C. Calculate the magnitude and direction of vector C. Well, magnitude is just the length of the hypotenuse. So this is 2, that's 3. So the magnitude, a squared plus b squared equals c squared. 9 plus 4 is 13. Magnitude can't be negative. Your spinner radius can't be negative, so we know our magnitude is the square root of 13. Now the direction, give me a second here. Well, let's just go for it. I wish I could draw, well, I'm going to draw bigger. So boom, boom, boom. So there's 3. Now, I kind of screwed up because I was in a hurry. That's actually minus 3. And this is positive 2. So if we find this, the question is that the direction? I'll talk about that in a second. So what we're going to do is we're going to realize this is my opposite side. This is my adjacent side. To find that angle, we can just use good old tangent of theta is opposite over adjacent. Now again, we're trying to figure this out in terms of degrees, so second tangent, negative 1.5, negative 56.3. So this guy is negative 56.3. Now, that's not a wrong answer, but a lot of times they want the positive spin. So if this is negative 56.3, a lot of times they're going to say, they're going to squeeze it into this window, which just means between 0 and 360. So if I go 360 minus 56.3, I get 303.7. Again, this isn't wrong. If it's fill in the blank, I wouldn't mark it wrong if they don't have this limitation listed. So in this situation, I would accept that, but really what they're looking for is how far the spinner needed to be spun, and that would be 303.7, or the radius. All right. What's a unit vector in the same direction? Well, that has its own little nifty little formula. So let me get that a second. So this is the formula. It's probably presented in different ways, but this just means 1 over the magnitude times the component vector. Well, we already know what the magnitude is. We found it's the square root of 13. And we just essentially need to distribute it through vector C. So if we distribute that through, we would get 2 over the square root of 13, negative 3 over the square root of 13. And to just check that, to make sure it's a unit vector, remember that means the spinner has been reduced to 1. If we just went a squared plus b squared, we would notice that'd be 4/13 plus 9/13, and that'd be 13/13, which is 1 equals c squared, and you can see that that would be length 1, just to check it. So this says take vector c, which we already found out is right here, 2, negative 3, multiply it by a half. So we're going to take 1/2, 2, negative 3, just follow the instructions, distribute it, so we'd get 1, negative 3 halves, or negative 1.5, and then negative 2c. So that would be negative 2 times 2, negative 3. This is just called scalar multiplication. It's just a fancy word for go ahead and distribute. And sketch it. Well, this one would be 1, negative 1.5. So it looks like right there. Negative 4, this is going to be messy, but negative 4, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And there's that one. Component form. That means it originates from the origin. Alright, so that obviously just changed its direction, and that just doubled the magnitude or its strength. Alright, well, determine the magnitude and direction of the vectors. Every picture tells a story. So these little pointy guys means it originates from the origin. 1, 2, 3, 7. I'm going to kind of, that's the point, but this represents the actual vector. So let's draw that vector in. So that's negative 3, 7. Magnitude, it's just Pythagorean theorem. So a squared plus b squared, I'm just going to make it 9, equals c squared. So c is going to be the square root of 58. And there's the magnitude. Now it says direction, which they want to know how far do you have to spin it. I'm going to use these two sides. Tangent, I'm going to put little alpha in there, equals opposite over adjacent, and then I'm going to use the inverse tangent to find that. So 7 over negative 3. Give me a second here. And second tangent, I'm going to put the negative with the 7, negative 66.8. So the calculator spits out negative 66.8. We've dealt with these before. So the question is, how can that be true? Because that would take me down 66.8. Well, the calculator doesn't know your math problem, so it's just spitting out a possibility. But as you can see, all students take Calc. Your calculator knows that tangent's negative in this quadrant or this quadrant, but it doesn't know our math problems here, so you got to do some thinking. If that's 66.8, so is this. Vertical angles are congruent. That's a geometry thing. So to figure out the direction angle, we got to take 66.8 and subtract it from 180, which let's just wing it, 103.2. There we go. All right, let's tackle this guy. Same thing. 1, 2, 3, 4, 1, 2, 3, 4, 5. That's a point, but this is a vector in component form. So that's 4, negative 5, a squared plus b squared equals c squared. C is right here. That's the magnitude. Take the square root, and we get the square root of 41. There's our magnitude. Now this time, put a little fishy there. I know this is the square root of 41, but I'm going to use the opposite and the adjacent to find this. So tangent of our little fishy guy, opposite over 4. So here we go. Second tangent, negative 1.25, is negative 51.3. So little fishy is negative 51.3, but when they want the direction, they're actually asking for this. So we have to go 360 minus that. So 360 minus 51.3, 308. So the direction angle is 308.7. That's how far you had to spin the spinner to create this. Done for now.